Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in exercise 5.1 33rd sum. Already in the last videos I have uploaded till 32 sums solution, so please do check it. Now let's start with the 33rd sum. Examine that sine modulus of x is a continuous function. So they're asking us to examine whether the given function is continuous or not. Okay. So if you notice here, the given function is a combination of two different functions. The one is sin x, other one is modulus of x. So we know that in a continuity, there is a one property like the combination of two continuous functions are continuous. So individually, we are going to prove sin x is a continuous function and modulus of x is a continuous function. Then combination of two continuous function, that is sine of modulus of x is continuous. So this is how we are going to prove the solution part of this. Okay, so given one, I'm going to consider as a f of x. Let f of x equal to sine of modulus of x. Okay, and I'll tell you how it is a combination of two different functions. That is, for that I'm going to take g of x as a sine x and h of x as a modulus of x. Okay, now g of h of x, so this can be rewritten in a form of g of h of x. And what is the h of x here? Modulus of x. Now for the g of x, whatever input it is, what is the output it's giving? Sin x in terms of sine. So here input is modulus of x, so it has to come as output sine of modulus of x. Okay, so that means sine of modulus of x is what? Combination of two different functions. Okay, it's a composition of two different functions. So we can say that separately g of x is continuous, h of x is continuous. That proof. Then combination of g of x, h of x is nothing but it's a f of x is continuous. Okay, so let g of x equal to sin x. Okay, now let's prove sin x is a continuous. Okay, for all the real values, basically we need to prove in a real line we have infinite real values. So I'm going to take, let c be the any real value, c be any real value. To prove the continuity at one point, what are the things are required? Suppose if you are proving some function is continuous at c, that means we need f of c value, left hand limit and right hand limit. All the three things are required, no? So now let's find out here g of x, no, that means g of c is required. So if input is x, outcome is sin x. If it is g of c, then it's going to be sin c. Now we have to find out left hand limit. Limit x is approaching to the c from the left hand side, g of x. Okay, what is the suitable g of x here? G of x is sin x. Now the left side closed values of the c are approximately c, but those values are less than c. Okay, suppose if you take number 3, the closed values of the 3 are 2.99. That point values are differing, no? So same way here, the closed values of the c of the point, the interval differencing will be there. So I'm going to make a substitution x as a c minus h for the left hand limit. Okay, and for the right hand limit, x as a c plus h I am going to take it. Okay, so now here x is approaching to c. Okay, that means in here if you replace x as a c, no, c equal to c minus h, c minus c equal to minus h, c minus c which is 0 minus h, that means h equal to 0, h is approaching to 0. Okay, so if x is approaching to c, h is approaches to 0. So now we'll change the limit condition as well. So limit h is approaching to 0, and what is the c value here? X value here, c minus h. Now we have a formula, that is sine of x minus y. So using that formula we are going to expand this. So limit h is approaching to 0, sin x cos y, that means sin c cos h minus cos c sin h. Now let's apply the limit in this. So sin c cos 0 minus cos c sin 0. Now sin 0 value is 0. If 0 is getting multiplied with any term, the complete second term becomes 0. And here cos 0 value 1, 1 with anything, it's the same thing. So sin c, then answer is only sin c. Now similarly we are going to find out for right hand limit as well. As I told you before, for the right hand limit I am going to make a substitution in place of x as a c plus h. Now right hand limit x is approaching to the c from the right side, g of x. So what is the g of x here? Sin x. As I told you, what is the x I'm going to consider here for the c? The right side closed values are approximately c, but those values are greater than c. So for the interval differencing, I'm going to take it as a c plus h. So replacing x as a c plus h. Okay. If x is approaching to the c, then h approaches to 0. As I explained here, the same condition. Okay. Now using that sign of x plus y formula, I'm going to expand this. So limit h is approaching to 0, sin c cos h plus cos c sin h. Now applying the limit, sin c cos 0 plus cos c sin 0. Sin 0 value is 0, then complete second term becomes a 0. Cos 0 value 1, 1 into sin c is sin c. So right hand limit result is what? Sin c. Now we have a result g of c, left hand limit and right hand limit. So g of c value equal to left hand limit and right hand limit. So from this we can say that g of x, no, g of x is what is the g of x? Sin x. So g of x equal to sin x is continuous for all the real values. Okay. So next we have to say that I told f of x is combination of composite function of a sine function and modulus of x. Next I am going to take h of x as a modulus of x. Now I am going to prove that modulus of x is a continuous for all the real values. So now let h of x equal to modulus of x. So modulus function, what we need to do first, we have to redefine the function minus x and x. So when we have to use the negative function if x is less than 0 and the positive function if x is greater than or equal to 0. So here two different functions we have. So throughout the real line it's not a single function. So using this if conditions we have to break the real line. Now we have these two intervals, okay, and one point. So that means three cases we are going to have. In a case 1, if x is less than 0, okay, we are going to check the continuity. Now at x equal to 0, which are going to check the continuity. Then if x is greater than 0, so in all the cases if it is continuous, then we can say the complete modulus of x is continuous for all the real values. Okay, now let's start with the case 1. So case 1, if x is exactly 0. So whenever we check the continuity at one particular point, we need what are the stuff? F of 0 value, left hand limit and right hand limit is required. Now let's find out f of 0. That means h here, h of 0. When h takes the exactly 0, what is the suitable function? Second function, h of x equal to x, then h of 0 equal to 0. Now left hand limit. Now from the left side it's approaching towards the 0. Left side closed values are less than 0, approximately 0 but less than 0. If it is less than 0, suitable function is first function. So limit x is approaching to 0, suitable function is minus x. Now applying the limit, same result we will get. Left hand limit also 0. Now right hand limit x is approaching to 0 from the right side. From right side closed values are approximately 0, but those values are greater than 0. If it is greater than 0, suitable function is x, so I replaced here. Now applying the limit, we will get 0. Now from this result, what we can say, h of 0 value, limit, okay, left hand limit and right hand limit are equal. So that means that h of x is continuous at x equal to 0. Okay. Now we need to confirm if x is less than 0, if x is greater than 0. In this particular interval also we have to check and we have to confirm that function is continuous. Now case 2. If x is less than 0. Okay, if x is less than 0 means that particular value lies in this particular interval. So in this particular interval we have infinite real values. Now I'm going to have some common name. Let C be the real value. Let C be any real value. At the same time condition applies, c should be less than 0. Okay, so as I told you here, to check the continuity we need three things: f of 0, left hand limit, right hand limit. Same way for the c, f of c, left hand limit, right hand limit is required. Now we'll find out f of c. Okay, and what is the condition for c? C is less than 0. No, if it is less than 0, first function h of x equal to minus x, then h of c will be minus c. So basically, we have taken C, which is less than 0, right? Now the closed values of the C from the left side as well as for the right side, both are less than 0. That means same first function only we are going to substitute in the for while finding the left hand limit and for right hand limit. So instead of finding it separately, limit I am going to find it together. Limit x is approaching to C. So that means both left hand limit, right hand limit together I am finding it. Okay, at the time. So this is h of C. Sorry. Uh, so h of x. So what is the h of x here? Suitable function. C is less than 0. No, less than 0 means minus x. So now applying the limit minus c. So from this what we can say, h of c result and limit x is approaching to the c, both are same. That means h of x is continuous if x is less than 0. Then finally we need to check the continuity for this particular interval. Okay, if x is greater than 0. If x is greater than 0. If x is greater than 0 also, we have infinity real values lies in this particular interval. So I'm going to have a common name. Let c be any real value. Okay, any real value. At the same time, c should be greater than 0. Now, to check the continuity, we need exact value and limits, left hand limit and right hand limit. Now, f of c. What is the c here? C is greater than 0. No, if it is greater than 0, we have to take the positive function, that is x. So, from the given, I'll show it. So, here we have a h of x. So, if c is greater than 0, that means positive function x we have to take. Then h of x equal to, that is h of x equal to x, then h of c will be c. Now, we have taken c over here. C is the greater than 0, right? Now from the left hand side, if it is approaching towards the c, and right side closed values both are greater than 0 only. So that means in the process of finding the left hand limit, right hand limit, in place of function we are going to use the positive function only. So that means when you use the same function, the result is going to be the same only. So instead of finding it separately, I'm going to finding it together. So now limit x is approaching to c, h of x. So h of x is the positive function, that is x. Now applying the limit, the result is c. So here h of c equal to limit x is approaching to c, h of x, both are same. So what we can say from this, h of x is continuous if x is greater than 0. That means from above three cases, the first case we have taken it as a at x equal to 0, and second case less than 0, third case greater than 0. So is there any discontinue point you notice? No. So that means we can say h of x is continuous, h of x equal to modulus of x is continuous for all the real values. Continuous for all real values. Okay. Now what are the above results? We found that h of x is continuous for all result, and before h of x, the g of x equal to, what is the g of x that we considered here? I'll show it one second. G of x equal to sin x is also continuous for all real values. No, sin x is continuous for all real values. So that means when two continuous functions, composite function also, that is also continuous. So that means sine of modulus of x is also continuous for all real values. So that's all. So the given f of x, that means whatever we considered as a f of x, that is sine, given function sine modulus of x is continuous for all real values. So that's all the solution part of this sum. Thank you for watching, and please do subscribe. Thank you.